This is GOCor, bringing globally optimized correspondence volumes into your neural network. In this work, we propose an alternative to the feature correlation layer, which is a fundamental CNN block in a wide range of applications. The feature correlation layer computes dense correspondence scores between an image pair in the form of a correspondence volume. It evaluates pairwise similarities between two feature maps by taking the scalar product between the corresponding pairs of vectors. However, the feature correlation layer produces an accurate matching confidence map with multiple high matching confidence values. Indeed, the ideal correlation looks like this, with a single high confidence value at the location of the matching pixel and zero otherwise. The reason for this inaccuracy is that each confidence value only relies on point-to-point feature comparisons. So for example, this value results from the scalar product between those two features only. And this is insufficient to disambiguate multiple regions with similar appearances, such as those two regions. But this region with similar appearances is also present in the reference image. In our work, we set out to design a correlation module that can exploit this extra information. More formally, in the feature correlation layer, the reference feature map is correlated with the query feature map to obtain the final correspondence volume. In GOCor, we instead generate a tensor W that we call the filter map. The filter map is then applied to the query features to obtain the final correspondence volume C. GOCor can thus be integrated in any architecture as a direct replacement to the feature correlation layer. But how can we achieve a suitable filter map W? W results from an internal optimization procedure minimizing an objective function L during the forward pass of the network. But how do we design L? As we said before, correlating this point of the reference with the query feature map gives an inaccurate feature correlation output. However, during test time, we do not know the location of the match in the query image, so we cannot use the ideal correlation. But we know that most similar-looking regions in the query, such as this one, are also present in the reference image. And when we correlate that point of the reference to the reference itself, the feature correlation layer also produces an inaccurate matching confidence map. But in this case, we know the location of the ground truth match. We can therefore generate a filter map W so that W correlated with the reference feature resembles the ideal correlation. We translate this into a regression loss over which we can optimize W. When optimizing on the reference loss, the confidence scores with both the reference and the query get more accurate. We additionally introduce a second loss which imposes learnable smoothness priors on the correlation output. But how to optimize fast? We use deepest descent iterations so that the optimization procedure only incurs minor additional runtime. We integrated GOCor into two popular architectures, PVCnet and GlueNet. On multiple tasks and dataset, GOCor obtains state-of-the-art results. This shows the generalization capabilities of our module. Thank you very much.